Let's talk about systems of linear equations. For example, we can have two equations and two unknowns, x and y. And we would want to find some specific values of x and y so that both equations are satisfied. A system of linear equations can be solved by using substitution. So from the first equation we could solve what is y. We will get y is equal to minus 2x plus 3. We can take this value of y and we can substitute it to the second equation. In this way we would get x minus 2x plus 3 is equal to 5. This gives 3x is equal to, we have a minus sign here, and if we shift the minus 3 to the other hand side, we'll get 8. So we get that x is 8 divided by 3. Now substituting the value of x here, we can get what y is. So that's how the substitution method works. Let's calculate some examples soon. In the addition method, we arrange the equations in such a way that we have some term with a plus sign and with a minus sign, and then we add the equations together. So here we would take the first equation and there add the second equation. We will get in total 3x plus 0y is equal to 8. So y is disappeared and we can get from here that x is equal to 8 divided by 3. Now we can substitute this value anywhere, for example here, and we can get what y is. Yeah, of course need to substitute where x is. Elimination method is something what you should use when you have more than two equations. And the point is that you don't get confused, you don't get lost. In elimination method, your goal is that you will try to first eliminate these x's from here, and then in the last equation you will eliminate y. And you will get your system of equations into a triangle shape. In this course we don't need the elimination method, but it's good to know this concept for the future. Of course, we can also solve systems of equations by using the computer. Let's now consider these two methods and practice them. Let's solve this system by using the substitution method. The first equation gives that y is equal to minus 2x plus 3. Now if we substitute this value of y to the second equation, we will get that x minus 2x plus 3 is 5. Let's open the parentheses. X plus 2x minus 3 is 5. We get in the left hand side in total 3x and in the right hand side 8. Dividing by 8 we get that x is, divide by 3, x is 8 divided by 3. Now that we have got x, we can solve for y. For example, we can take the first equation and leave just y in the left hand side, and in the right hand side we will get minus 2x plus 3. Okay, we already had the thing written down here, but no problem. And here let's substitute this value of x there. We will get that y is minus 2 times 8 divided by 3 plus 3 minus 16 over 3. 3 times 3 is 9. So in total we have minus, okay, 16 minus 9 is 7, so we have minus 7 over 3. So the answer is x is 8 divided by 3 and y is minus 7 over 3. It would be good to check the answer. If we would check both of these equations, the first equation would give 2 times 8 divided by 3 minus 7 divided by 3. Well, 16 minus 7 is 9, and we get 3. So the first equation is satisfied. We have 3 in the right hand side. How about the second equation? X is 8 over 3, and we should subtract from there 7 over 3. We will get 8 plus 7 is 15. 15 divided by 3 is 5. We got 5 as we should get. So everything is okay. Let's consider another example. In this example, the equations are written in a little bit more messy way. We have variables y also in the right hand side. If we work with the substitution method, we don't have to really care about this. From the second equation, we can easily solve x. So we get that x is 4y minus 3. We can substitute this value to the first equation. This gives 7 times 4y minus 3 is equal to 3y plus 1. Opening the parentheses, we get 28y minus 21 is 3y plus 1. Shifting all y's to the left hand side, we get 25y is equal to 22. From here we get that y is 22 divided by 25. Now that we have solved the value of y, we can substitute it to this equation. We have 88 divided by 25, and we can write 3 as 75 divided by 25. (88 minus 75 is 13. Now that we have got both x and y, we can state the answer. Here's the answer. Let's now practice the addition method. We should a little bit modify the equations so that when we add the equations, something would cancel out. We have here 2y, and if we could make here minus 2y, then while adding the equations together, y's would cancel out. Following this idea, let's take the first equation and multiply it with minus 2. We get minus 4x minus 2y is minus 12, and we can keep the second equation as it is. Now we are ready to use the addition method. We have in total minus 1x, the y's cancel out, and in the right hand side we have minus 21. So x seems to be equal to 21. If we really wanted to, we could modify the equation in that way that we can also, by addition, remove the x's. We could do that. This not so smart way would go as follows. We could multiply the first equation with minus 3 and the second equation with minus plus 2, and we would get minus 6x minus 3y is minus 18, and the second equation is 6x plus 4y is minus 18. We are now multiplying the first equation with minus 3 and the second equation with 2. Now summing these up, the x's will cancel out and we get that y is equal to minus 36. So we got both the values of x and y by using this addition. But because we have already solved x, the smart way is to substitute. Let's take, for example, the first equation. From there we can solve y. Y is equal to 6 minus 2x. We can substitute the value of x here, and we would get 6 minus 42. This gives minus 36. So in the addition method, the best practice is to use addition to find the first unknown, and then to find the second unknown by using the substitution. Let's in the next video talk about different things what can happen, what is the meaning of the solution, and sometimes the systems of equations don't have solutions, or they can have many solutions. Let's talk about this in the next video.